Afternoon, everyone, or good morning, depending on where you are. We're going to get started in just a couple of minutes. Just see a lot of people still filtering in. Okay, actually, before we start, I'm just going to run through a couple introductory slides and some housekeeping. Matt, if I could just get you to advance the slide. Thank you. So we do often get people asking about our services and locations after our webinar, so I'm just going to run through this quick. Origin and Cause is a forensic engineering and fire investigation firm established over 30 years ago. We're the largest of our kind in Canada with 17 locations and over 45 experts. We are in Ancaster, Calgary, Edmonton, Halifax, Kingston, London, Mississauga, Orillia, Ottawa, Regina, Saskatoon, Sudbury, Sydney, Vancouver, Vancouver Island, Windsor, and Winnipeg. And our services include, Matt, I can get you to fire and explosion investigation, mechanical engineering. We'll kind of be covering both of those today. Structural engineering, materials engineering, or materials, product, and equipment failures, electrical engineering and alarm system analysis, chemical engineering, forensic fire protection engineering, drone inspection services, and forensic litigation services. Okay, so let's just go through a couple housekeeping notes here. Again, welcome everyone, hope you're all doing well. So we're going to be doing a live Q&A at the end of the webinar, so please feel free to submit questions at any time throughout the webinar, but we'll just be getting to them at the very end. So there's the questions drop down in your GoToWebinar control panel. You put them in there. Likewise, any technical difficulties, go ahead and drop a question in there and I'll see if I can help you out. We will try to get to as many questions as we can within the hour. If we don't get to your question, we'll follow up with an email just to make sure everyone gets their questions answered. Quick disclaimer, all information discussed in this webinar is for educational purposes only. It should not be applied directly to the administration of any particular file or claim. This webinar is being recorded and we'll be posting the video on our website, linked in YouTube, so please feel free to share this with colleagues if you wish. We will be sending certificates out to everyone via email. We try and do this as fast as we can, but we're a pretty big group today, so it does take a little while. We are accredited in Saskatchewan, Manitoba. It's eligible for accreditation in British Columbia. We're just waiting on Alberta. We should be hearing from them soon. And I think that does it for me. So why don't we get started? I'm going to pass things over to Matt.
All right, thank you, Mark, and thank you everyone for attending the presentation. I am going to be talking about agricultural equipment fire losses and trends we see with the changing seasons. Just a little bit about myself. I'm a mechanical engineer. I'm based in our Winnipeg office, and I'm a licensed engineer throughout Western Canada. I've investigated over 800 different losses of various types. Based on that, my background and location, a number of those losses have been related to agricultural equipment and fires. Most agricultural operations are typically tied to the changing seasons. Because of this, different equipment is operating at different times of the year and in different operating conditions. Therefore, there's some seasonal fluctuation with what fire-causing incidents we investigate. In this presentation, I'm going to be discussing the different conditions, the different work being conducted, and some of the more common fires in each season. We'll start in the spring and look at seeding and planting operations. Then I'll move into the summer. We'll talk about haying in the fall and harvest time, and then we'll finish up in the winter and talk about fires in equipment related to working with cattle. So this isn't to say that, all types of fires can't occur at any time. It's just that some are more common at certain times of the year. So we're going to start in the spring. It is finally spring here. It was a bit late getting to spring, but we have had really good weather in the field since. So the bulk of planting is done in this area. agricultural operations in the spring include preparing the fields and seeding. Typically, there is less organic material present at this time of the year. In this picture, you can see that we do have some stubble under the tractor, but you'll see later on in the presentation that some other times of the year, there's a lot more organic material present. So hot surface with organic material is less of an issue at springtime. Some things we do see is that, as manufacturers are coming out with new equipment, that equipment is getting larger and larger. So we're seeing bigger seeders, bigger grain carts, and that essentially results in larger loading on the tractor, increased load, increased temperature, but also you're putting more stress on engine components, hydraulics, that kind of thing. So increasing that load kind of increases the potential for a failure. The other thing that happens is that because this equipment is not in use through the winter, a lot of that major off-season service work can happen through the winter, and spring is the first real test to see how that servicing went. And so there's the potential for failures related to service through the spring as well. Here's an example of a tractor that was operating in the field. This was pulling a harrow, so prepping the field. Harrows used to kind of overturn the soil. It was a large tractor, but operating under fairly heavy loads just because of the conditions. The operator was in the field, was operating without issue. All of a sudden heard a bang, lost power, and there was flames coming from the engine compartment. This fire did spread very rapidly. The operator shut the tractor down, exited the door here, and then actually had to jump off that top step because there's already flames coming around that area, even though he'd exited the tractor basically as soon as he saw the flames. Service work was conducted on this tractor during the off season, and that work included replacing one of the two turbochargers on the left side of the engine. Here's a view of that left side of the engine. Exhaust manifold here, and the exhaust is routed into this first turbocharger. Exhaust then goes down to the exhaust side of the second turbocharger and then out the tractor. On this second turbocharger, you can see that the intake side is present, but we don't have that on the first turbocharger. Now, it is possible to get a large enough fire to melt off this intake side. Because it's cooler, it's made of aluminum, so it does have a lower melting temperature. So it's not uncommon to see a turbocharger that the hot side's fine, but the intake side's melted off. In this case, however, we do have a fractured section of that intake side of the turbocharger just sitting down here in the engine compartment. It is not melted, so although we had some melting damage around here, this shows that that part of the turbocharger had actually fractured prior to the fire occurring and resulted in the fire. So here's a cutaway of a turbocharger. Again, exhaust enters the hot side, spins the vane in here and then exits, and that in turn spins the shaft, which runs the compressor vane. Air is incoming, pressurized, and then sent to the engine under pressure. The profile right here of the intake side of the turbocharger is actually what we're looking at right here. And it's actually if you flip this over, that's what we're going to be looking at. And you can see some scraping damage on the housing. And this damage occurred as that compressor vane kind of blew apart and fractured the turbocharger. So we know turbocharger failed, that resulted in the fire. Now we got to be looking at whether or not this was an installation issue or a manufacturing issue. The turbochargers are supplied with oil. So there's an oil inlet here coming off the engine, and that's going to be lubricating these two bushings. The reason for that is then once the shaft spins, it's essentially spinning on a film of oil, so you don't have any rubbing damage on that metal. In this case, we were able to confirm that, that oil line was connected properly. There was oil supplied to this turbocharger. So the failure in this case was due to an internal issue with that turbocharger. So now we're going to move into the summertime. Agricultural operations in the summer, we do see some spraying chemical fertilizer in the field. We don't really get as many fires with that equipment. Sprayers are, there's still an engine, so there's still the potential for fires and failures there, but due to the layout, the amount of work and the loading on it, it's less of an issue typically. Haying is also occurring through the summer. Haying is a multi-step process where you're first cutting that crop. So cutting the hay, could be a mower, could be a haybine, possibly raking it, just depending on the conditions. Baling the hay. This picture here shows a round baler, could also be square baler, and then those bales are transported off the field. Prior to the hay being cut, it is wetter because it is living, but once it's cut, it starts to dry out, and so there is more organic material in the field. Here you can see that we do have a lot more material than just that stubble that was present in the springtime. And we have equipment kind of moving in and out of that field, in and out of that location throughout the process. So there's going to be hot surfaces present, engine, exhaust surfaces on the tractor, and also rotating components on the baler. And essentially, really the baler is designed to pick up and store that organic material. So there is going to be material collected in the baler, and there's a potential for ignition of that material. Now, manufacturers are cognizant of the fact that, these are the operating conditions. So owner's manuals will have sections on cleaning that the operator needs to follow. And that's another thing that needs to be considered when we're looking at fires involving hot surface ignition. So I'm going to pop up kind of an animation of a baler operating. Basically, it's starting to pick up the hay through the pickup in the bottom as it's traveled along. It rolls in here, and you can see that there's a number of rollers throughout, and a belt helps to keep pressure on that bale in order to keep everything in the right place and also keep it larger and packed. After the bale is produced, then it's wrapped in order to keep it all together once it's ejected out of the baler. It used to be twine that was used. Now we see a lot more net wrap that kind of just does the whole thing at once. It's a lot quicker of an operation. And then once that bale is wrapped, it's ejected, kicked out of the baler, and it can be pulled along to start getting new material in there. So here is an example of a baler after a fire. This baler was operating in the field at the time of the fire. It had most of a bale inside, but it hadn't been wrapped yet. As he was about to wrap it, the operator looked back, noticed some smoke coming from the baler, so stopped, was able to unhook the tractor and save it, get it out of the way, but unfortunately was not able to suppress the fire. And a couple days prior to this fire occurring, there was 2 rollers and some belts changed inside the baler by a third-party service company. So now we're looking inside the baler. As I pointed out in the previous couple slides, there was a number of rollers around the baler. And this roller you can see is actually not connected where it should be. This guy should be connected up here. So the right side had fractured. It's still properly connected on the left side. And then close up of this area where it would be connected, you can see that there's some rubbing damage here in the side of the baler itself. And this is essentially during that failure, as it's spinning, the side of the roller is contacting the side of the housing. That's going to be producing a lot of friction and heat right here. But the other thing it's doing is wearing away some of this metal. And that's going to kind of eject it out of here, similar to grinding operations. But as we showed earlier, there is a bale being produced right here. So any kind of metal coming down here is going to get wrapped up in that organic material, can lead to some smoldering and then eventually flaming ignition of that material. I'm just going to go back a couple slides here just to show the side of the baler. There's a device right here that is a centralized grease port. There's one of these on both sides of the baler. Basically, the grease is supplied there, and then these lines take it to different locations throughout the baler where the grease is required. This bearing did have one of those grease fittings coming from the centralized port. It was fractured and damaged, but it was still attached in the proper location. And there was evidence that the other bearings on the baler were being greased. So it did appear that the standard greasing procedure had been followed. This is that incident side of the roller. This is where the bearing would be located, but the bearing was not present. So not only was there that rubbing damage on the side of the baler, but essentially the whole bearing could have got wrapped up in that bale that would have been hot enough during failure to ignite it. And this is the opposite side of the roller. This was the intact bearing. So basically the inside of the bearing is around that roller, secured to the roller. And then there's the rolling items in here. In this case, it's a ball bearing. So there's a number of steel balls in there. And then the outer race was secured to the side of the baler. So because it's just steel on steel, you do need that lubrication in there. So potential for failure if there's improper lubrication, but we're able to show that that wasn't the case this time. So this did come down to a problem with the installation of that bearing after the recent service was conducted. Here's another example of a baler that was being operated in the field at the time of the fire. This picture makes it look a little more like wintertime than summertime, but sometimes that's just was a bit of a delay between us getting involved in the file. The reported information that we received was that the baler was in the field, was operating. They had no troubles operating. Farmer kicked out the last bale, went and parked the tractor and baler. Always parks it kind of behind the stand of trees so it's not visible from the road. Left for the day, came back to get it and start baling again, and he found it in this condition. Interesting fire patterns to note on here is that, you know, we do have a lot of fire damage at the back of this baler, and we do have a lot of damage at the tractor, but there is less fire damage through the middle, not a lot of patterns to support either fire spread from the tractor to the baler or from the baler to the tractor, at least visible in this photograph. Again, we're looking at rollers in that baler. There are a number of rollers throughout, and you can see that there's another one here that is not in the proper position. It's fine and connected on the right side, but not connected on the left side here, either a bearing issue or a bolt issue. But when we look a little closer at the side of the baler itself, we can tell where the roller isn't connected, but we don't see any of that same frictional damage. There's a little bit of rusting and some fire damage, but we don't have any deep gouges or anything to indicate that, yes, this failed during operation. Well, I guess just one more thing to notice at the back of this baler as well. as there's actually a second roller that's also out of alignment. Once again, it's connected fine on this side, but over here is no longer connected and is similar to the upper one in that there's no frictional damage on the side of that baler. Now this is moving into the area between the tractor and baler where the baler is connected. There's a hitch on the tractor and there's one open hole, but just the way this U-hitch was designed in this, it might not look like it, but the baler was properly connected to the hitch. PTO also connected, but up here is where the electrical connection between the baler and tractor would be. So in the tractor, there's going to be a monitor to run the baler. We'll give output on how the bale is forming, weight, speed of the tractor, and if it needs to speed up or slow down, and also on controlling the wrapping. In order for that to all be output, the electrical connection would need to be connected. But in this case, the electrical connector was just kind of down by the hitch, laying into this organic material. And we can see some of that it actually melted and adhered to it. So this connector was definitely not connected at the tractor. Also, the way it was wrapped up here, it was physically not possible to stretch it all the way to where it needed to be connected on the tractor. So basically, the fire patterns don't really connect between tractor and baler. There were multiple broken rollers, but no evidence that that resulted in heating damage at the baler itself. And we can show that the baler wasn't even connected in the way that the owner said it was. So from this investigation, there was enough evidence to indicate that this fire was intentionally set. So now we're going to move into fall time and harvest. There are a number of different processes that go along with harvest. Seen in this picture, the field is being combined, so there's a combine operating, also tractor and grain cart as well. And you can also see that there is straw here coming off of the combine. And that can also be baled. So we have tractors, combines. If the grain's cut prior to the combine, swather would be used and that's just picked up by the combine. And I'm also going to touch on grain dryers at the end. It's also different in the fall time than summer because you can see that the crop's allowed to mature, needs to mature, but that also results in it being drier. So there is more potential for a dry material to build up as opposed to the wetter material during haying time. So it's a little even more potential for fire resulting in the conditions. Typically as well with harvest, just depending on the conditions, it's possible for the combines and harvesting to be completed for long hours, even around the clock if the conditions are right for that. But that does kind of create other issues in terms of servicing, proper cleaning, third-party servicing. If anything goes down, they're usually more of a time crunch to get that fixed. So that has the potential to bring in other issues related to service. Also, like anything, emission standards are increasing, and that is resulting in hotter exhaust temperatures all the time and other means that the manufacturers use to mitigate those emissions. And so that's just, again, increasing the potential for fires related to hot surface. This is just the opposite side of that same combine. All the plastic has been conveniently removed. And so we do see that there's also a number of rotating components present on the side of the combine, some down here as well. And there's going to be bearings with all these components that have the potential to get hot. The different service intervals for different bearings that are present. There's some, the header's not attached here, but there would be some in the header that service interval could be as frequent as every 10 hours. And then moving into other parts of the combine could be as much as 400s on what kind of greasing is required. So, if this combine is operating around the clock, then that's going to be stopping just to grease the bearings 2, maybe more times per day to follow those recommendations. Now, like I said, there's possible for bearing related failures to occur and to cause a fire, but that's not the only potential fire cause on a combine. Here is the battery on the left side of this unit. Battery cables go up into the engine compartment, connect to the starter, wrap around under the engine to the alternator. So there's primary wiring on both sides of this engine. There's also secondary wiring throughout. And so there's always the potential for electrical failures. We do have exhaust up here coming off the engine, so there's hot surfaces that aren't bearings. That could be hot surface ignition fire causes as well. In this case, the wiring coming off that battery was secured to the body of the combine. Then it was routed around a bracket and connected to the starter, which is fixed to the engine. During operation, there's going to be some vibration of the combine while it's operating. And when the engine is operating, it's also going to be vibrating, but they're not going to be vibrating at the same frequency. So because of that, and just the way the wiring was routed, there was some rubbing damage on that insulation on the wiring. And that was sufficient to rub through the insulation, cause a short circuit failure, and that electrical short started the fire. And here's another combine that was operating in the field. This one was operating for several hours, but in this case, they didn't really get going until, I think it was around noon. Fire was closer to 4 or 4:30 in the afternoon. And so the farmer said that that does give them a chance every day to, open up the combine, open up all the covers. They would use a leaf blower and blow out all the organic material that collected that they could get out with the leaf blower. And they were also able to show that they have been following the recommendations on how to grease and service those bearings in the combine. In this case, fire occurred on the right side of the combine. It actually wasn't the combine operator that noticed the fire. It was a grain cart operator also in the field, saw a fire kind of in this area on the combine, radioed the combine operator, who then shut down, still had no problems operating the combine, got out, tried to suppress kind of fire in this area with handheld extinguishers, but was not successful. And here you can see on this combine that we do have a number of rotating components. There's going to be bearings at several locations throughout that need to be examined. Now, it is possible for bearings to get hot enough to ignite organic material that has collected on them, and that bearing could not fail but still could ignite the material. But this isn't something that is very easy to identify post-fire, because if the material burns away and the bearing doesn't fail, then we don't really see evidence of it. But it is not possible for a bearing operating in a combine or resting in a combine to be attacked by fire and that cause it to fail. So in this case, we have clear evidence of a bearing failure, and this would have had to have happened during operation of the combine, and is most likely what started the fire in this case. This is an example of an exemplar bearing. Here is the bearing housing, and you can see that the shaft is centered in that bearing housing, and the seal on the bearing is intact. So everything on this bearing is okay. We move over to the incident bearing, same bearing housing, but that shaft is no longer centered in the housing. That's because we're missing all of the rolling member of this bearing. In this case, it was again a ball bearing that failed. And this is a picture of the inner race. So this is the shaft was cut out. And you can see that there's a crack along here. So the inner race itself was fractured. And there's also some smearing damage to the metal here. So there's some metal damage on the inner race. There was some damage to the outer race. And also all the ball bearings from in here were steel. They were ejected from the bearing. I did find a few of them. I think 3 or 4 bearings were found kind of loose on the combine, and some of them did have damage to suggest that there was, you know, heat and friction sufficient enough to kind of wreck that steel material. And once those get ejected, there's the potential that they could land in an area where organic material can collect on the combine, which is what happened in this case, and that ignited and led to the fire. Now again, we know that this bearing failure occurred and that's what started this fire, but still need to look at servicing of the bearing. You know, could this be related to improper servicing by the owner? Was the bearing recently changed? Is this a material issue, or was there kind of third-party maintenance issue? Or are we talking about a manufacturing defect? One thing that happens with ag equipment that is not as convenient as it is with passenger vehicles is for passenger vehicles, there's Transport Canada and all our recalls are published. So it is possible to, you know make and model and year of a vehicle and go find all the published recalls. It's not the same for ag equipment. For passenger vehicles, it's a life safety issue. So it is more tightly regulated, where for ag equipment, there's not the same recall process. Manufacturers might have their own internal recalls that probably aren't even stated as recalls, but they have product improvements or something like that that they put out. But it's a lot harder for us to collect that data because it's not published. In this case, there's no published recall on the bearing itself, but it was noticed on the next model year of combine that a larger bearing was put in the exact same location when none of the other configuration had changed. So although there's not a recall out, this does suggest to us that the manufacturer has identified an issue with this bearing, and so address the issue on the subsequent model, and that indicates that there's a design issue here, which is what caused the fire. And lastly, in the fall and harvest time, I'm going to talk just a little bit about grain dryers. Grain dryers aren't used every year, so it's going to depend on harvest conditions, what the moisture is like in the grain, the toughness, and you can get large grain dryers at terminals down to much smaller dryers. Farmers might have their own individual dryers. We also see both continuous style or a batch style dryer. The way a batch style grain dryer would work is that dryer would be filled with grain, heat's applied to dry it, and then that dry grain is removed and the next batch can be brought in if required. This here is an example of a continuous style grain dryer. So grain enters the top, gets augured along to fill this column, and then it just slowly falls down the side of the dryer. There's going to be a grain column on that side and on the back side of this one. And then they would meet at the discharge auger and out and taken for storage. Over here we have 4 gas burners. So they are supplying hot air into this plenum. A couple of fans here blowing that air in over the burners and filling the plenum. You can kind of see little red triangles in here. So that hot air is exiting that hot air plenum through those triangles. It is going through the grain itself and then exiting the side of the dryer. and it's drawing out that moisture as it goes through. There's also a cooling section down here. Some dryers are set up with a cooling section, some aren't, and some it's optional. In this case, it looks like it's optional because there's another burner right here, but when that burner is off, you're essentially just bringing ambient air in to cool that grain prior to it being sent for storage. So basically, with a grain dryer, you light a big fire and blow that towards ignitable material. So there's definitely the potential for this to end badly and cause a fire. Potential failures could be related to burner issues, could be a burner malfunction, improper combustion causing problems with that burner. Grain dryers are going to be supplied with either propane or natural gas. So if there's an issue with the gas supply, if the wrong gas is supplied, that can cause an issue. Also, there's measurement devices throughout the dryer. So there's going to be temperature sensors in the hot air plenum. There's going to be temperature sensors in the grain, air proving or airflow sensors, that kind of thing throughout. And if you have a problem with some of those sensors, maybe the burner is being asked to supply more heat than is required just because that sensor is not working. It's also possible to get a problem with fans and airflow. If you don't get that proper airflow through the dryer, it's possible that localized hotspots will be created, and that could lead to issues. And also, you know, that hot air plenum is typically set hot enough that it would ignite the grain if it's left in there long enough. So that grain needs to be flowing through the dryer. If there's a problem with it not flowing, or if there's any kind of like localized area where it doesn't flow, then there's the potential that you could ignite the grain that's stuck in the dryer. This is an example of a very large grain dryer that I looked at outside of, well, rural Saskatchewan. The dryer itself was 80 feet tall. There were a number of burners that aren't visible here, but they're on the back side of the dryer. So they're putting heat into the dryer, grain that flows through the middle, and there are some fans at the top that are drawing that heat through the grain and out of the dryer. It also looks like this one had a cooling section that I would say is about that large. And there's two fans at the bottom for cooling that grain prior to it going into the bins for storage. Here's a top view of that dryer. Burners were in this section here. Hot air is sent up through the top of the dryer. Grain enters the top in here, and this is the grain column, so the grain would slowly flow through the dryer and out. And like I said, there are a number of fans at the top of the dryer in this location that are going to be pulling that hot air through the grain and exhausting it out the top. Here's that same dryer with some of the outside sheeting around the fans removed, and we can see that there's one location in the dryer where it looks like we have a lot more damage, more localized damage, and this is a possible area of where the fire started. One of the things that with this grain dryer is that there were a number of temperature measurement areas in the dryer. There was also a lot of that historical data was saved, so we were able to look at temperature, airflow through the dryer for multiple days leading up to the incident to kind of aid with that investigation. And unfortunately, like every year, we once again have come to winter. We don't really see fire losses in the winter related to tractors in the field because they're not in the field, but we do still see a lot of fires related to tractors or equipment working with cattle. Typically, this could be something like a bale shredder, which is essentially a large blender. Those bales that were produced in the summer and the fall, you'd put a couple of these into the bale shredder, pull it behind the tractor, it would chop off that bale. In the front here, we would have hay that is used for feed. So the shredder has chopped up that hay, laid it along here for feed. You might also have straw in the pens as well as bedding. So we've essentially just moved that organic material from the field into here. And as you can imagine, if you put a bale in a blender, especially when you put a little bit of wind into the equation, there's going to be organic material essentially flying everywhere. There's also a few other challenges with winter. It's a lot harder to clean and maintain equipment, especially if it's in an area where you're getting lots of freeze and thaw. Some of this material may be, thawed enough to stick, and then it gets frozen, and so it could be very hard to clean out and remove organic material that is collected. And there's also other issues with things freezing and breaking, maintenance being harder to conduct, that kind of thing. I, over the last few years, have looked at a number of fires related to a specific manufacturer, a couple manufacturers, and fires around the SCR. This picture is in the springtime, but I do see more of these in in the winter related to cattle operations than any other time of the year. I just used this one just to give an idea because the engine and exhaust are pretty visible. But here's the engine in the tractor. Exhaust goes out through the turbocharger and then comes down into the base of this tank. This is the SCR tank. SCR stands for Selective Catalytic Reduction. And it's basically a tank where those exhaust gases are going, and there's filters in it to help take out some of those harmful particles so that emission standards can be met, and then it's sent to the atmosphere. Typically, when it's like springtime and they're in the field, they're going to be operating for a lot longer. So they might be under more load, but there's less organic material and there's more cleaning that happens. It's the kind of thing that in the winter time, they may be used for 20 minutes to an hour a day, and that's it. So it's more organic material around, but also there's less cleaning that may occur in the wintertime just when it's not used as often. So here is an example of a similar tractor, same setup anyways, and you can see that the SCR tank's not visible because it's shrouded in plastic. Reason for that is that these tanks do get hot, so it is a personal safety issue. So the manufacturer will cover this in plastic so that someone doesn't lean on it and accidentally get burnt. Problem for that is that it just makes it more onerous to clean. I have taken all the plastic off, cleaned that tank, put the plastic back on, and it's taken me close to an hour. In the owner's manual for these tractors, the manufacturer recommends cleaning off all exhaust components once a day. But as you can imagine, who's going to want to spend an hour cleaning this every day and then using the tractor for 20 minutes? So here's just a closer view of that tank. This is with all the plastic still on that would need to get removed for the cleaning. And here you can see I have taken some of it off. This exposes that metal tank, but you also see that there is this air gap between the tank and the plastic. And if organic material collects in there, it is hard to remove that material. Here's an example of one of those tractors post-fire. This one wasn't a very large fire, so we do have some fire damage at the back of the engine, and there's also fire damage through the cab more on the right side. But the damage itself is centered around this SCR tank, which you can see is half visible. Reported information, everything was operating fine. The operator saw some smoke coming up here, and we got out, saw a little bit of fire kind of down in this area. But if we go back one, with fire kind of in this area, that's basically the first opening above the SCR where that fire kind of exits the tractor. So here is that same tank with some of the plastic removed. This is the exhaust entering the base of the tank. The exhaust is going to be hotter in this location just because it's closer to the engine where it's being produced. It's slowly cooling throughout. But that means that this is the hottest spot of where the exhaust enters. And there's some glass in this area post-fire, but we also do have a collection of organic material. Some here, there's a lot more on the backside, and then some even caught above that Y there. And after peeling that material away, I did find organic material that was pressed up against the SCR tank. That material had decomposed and was charred and burnt, and that fire pattern showed that, you know, the fire started right adjacent to that tank and spread up from there. So in this case, the cause of the fire was a result of ignition of combustible material against that SCR tank. Now, I have done several joint examinations with the manufacturer. Every time they've said that, you know, these tanks don't get hot enough to ignite material. They've done studies of their own that show this. I've asked to see the data and results of those studies that they collected, but they always tell me that it's proprietary information, so I don't get to look at it. So they say they've done studies to show what temperature it gets to, but they're not willing to share that information. We have started to do our own test where I've got a tractor that I'm fitting with thermocouples around a few different locations on this tank. Then I'm going to be having the farmer operate as normal. We're going to be measuring the temperature on the tank at those locations. Then after the first test is done, I'm going to be wrapping the tank in insulation to simulate organic material buildup around that tank. And then we'll be able to see if, you know, maybe a clean tank only gets to a certain temperature, but once that tank is insulated and operated long enough, we might get higher temperatures, and those temperatures might be enough to ignite organic material. So just a few takeaways from the presentation. We started off in spring, and as I said, it's not uncommon for service work to be conducted before spring. Just a lot of the equipment is down over the winter. So because of that, spring becomes a first real test of some of this maintenance. It is important to collect that information on off-season maintenance just to see kind of what maintenance occurred so that we can compare that to what the fire damage was, compare that to the fire cause and see if that maintenance could have resulted in the fire. Kind of throughout the different case studies, I tried to show that, you know, we might come to a fire cause, might see that, like, yeah, we have this bearing that failed, but there's still a few different reasons for that failure that need to be considered. So is this a result of lack of maintenance, not enough grease in by the owner or operator of that? Is it possible that there's a manufacturing defect that led to the failure? Is it something to do with recent service? Or could it be equipment design issue, like that one combine where the heavier bearing was put in? So it's one thing to come and determine a cause, but then there's also work that needs to be done to try to attempt to determine the reason for that fire cause and who's at fault. And then lastly, exhaust temperatures are hot. You know, emission standards as are improving, those temperatures are still rising. And, you know, there's organic material present in the environment. These machines are designed to work in those conditions. So as much as we know that there is that heat produced, it's also up to the manufacturer and the owner and everyone to really attempt to do what they can to clean it, to make sure we don't get those hot surface ignitions. But we do need to compare what kind of requirements there are for the owner in terms of cleaning and compare that with what is reasonable. Because if we're talking about that last one where it could be up to an hour just to clean the tractor daily, then it's going to be a question of whether or not that is reasonable to have the owner do on a daily basis. So that
Thank you so much, Matt. Oh, sorry.
Hey, from.
Go ahead. Go ahead.
I'm just going to say that that's the end of what I prepared, but we can go through any questions. I'll also just leave my contact info, like Mark said. If we don't get to your question or if anything pops up later, feel free to reach out, shoot me an email or give me a call and we can discuss.
Yeah, fantastic. Yeah, we do have some questions already, and I see more coming in. So let's try and get through as many as we can. Question number one: do any manufacturers install fire suppression systems on balers?
I have not come across any yet. I was talking to a John Deere investigator a few weeks ago. We were looking at a combine, but we were just talking about fire suppression systems, and he said it's not really on the radar either on the manufacturer side. I know there's some third parties that, you know, depending on the owner, they might want to get them installed, but I haven't come across it or seen it, and I don't know if it's something that is coming or not.
Interesting. Okay. Do you find that smaller farms tend to not use the appropriate matches for baler to tractor, and thus not connecting the wiring to baler and tractor, and more or less just pulling it around without the monitoring of the electrical system?
It's an interesting question. It's not something I've come across. I'm sure it could happen. I know, just like you said, that's going to be more probably for smaller farms or older equipment. I know a lot of the newer equipment, it's a lot harder to operate without electronic controls. So the electronics that are getting involved in this equipment is increasing all the time.
All right. Are most fires on modern combines emissions related?
I don't think I would say most. It seems to be a reasonable mix. There's definitely going to be stuff that's emissions related, but I find that a lot of those ones are maybe a little smaller or slower growing fires. So it's more often that those are picked up and caught. If we get something like the electrical failures or engine issues or bearing failures, those tend to lead to bigger fires just because more heat's produced. So I would think that I get a reasonable mix of all different types, but it's possible that there's a lot of those hot surface due to emissions related equipment that I just don't end up seeing because it's not a big enough fire.
Okay. Let's see. Wow, a lot of questions. Could the overuse and potential excess road exposure lead to overuse that causes a fire, a machinery fire?
I think it would be hard to quantify what overuse is, because if they're set up to be used, as long as they're, you know, as long as the tractor is being operated within the parameters of how it can be operated, I don't think it could really be overused. Maybe you'd be looking at more of an improper maintenance, or if there's other stuff that, you know, based on use is not getting covered or not getting looked at enough, then maybe that could lead to what you're seeing in terms of a failure.
Okay. Do most fire losses on machinery end up being total losses?
I'm probably not the right person to ask, just because I'm going to get brought in on a lot more total losses just because the dollar value is higher, so there's more interest. But it's whether or not there's fires that are smaller that we're not brought in on. So it's hard for me to compare that. I would say when I'm looking at equipment fires, then most are going to be total losses. Definitely, I would say for sure more than half of them are total losses that I get brought in for.
Okay. If it's a known issue that organics settle at the bottom of the SCR cover, why not change the design to eliminate a closed-in cover?
That's a good question. There's some, just depending on the model and size of the tractor, some of them are set up a little differently. There is a little bit more opening at the bottom, or almost like a grate at the bottom that helps some material fall through. I think the problem with saying that it's a known issue is then the manufacturer might have to admit that it's a known issue. And based on what I've dealt with in terms of joining exams and discussing with them, they're definitely not on board with saying it's a known issue at this time.
Yeah, okay, that's fair. How about what percentage of success is there in chasing manufacturers being their equipment fails?
Unfortunately, the problem we have is that once our investigation is complete and I've sent my report in, I typically don't hear about whether or not it's successful or not. So I don't think I would have all the information on that. I know there's definitely instances where when we have good evidence, the insurance company is able to recover. I don't know kind of what percentages in terms of how much of that loss they recover or how often they would be able to.
Right, thank you. Let's see. How long does the grain drying process typically take?
It's gonna depend on the dryer. There's actually a lot of factors. Different grains will dry at different different rates. There's even a lot of variation with what moisture percentage the grain is going in. You could have something at 15% that you want to get down to 13%, or you could have something at 18% that you want to get down to 14%. So it's going to be changing a lot on that. And then there's a lot of variation on size of the dryer. I would say if you're looking at kind of a typical dryer that you would have just at the farm, continuous style operation, you're probably looking in the 20 to 40 minutes from top to bottom for that grain to flow through the dryer. But again, there are a number of factors.
Okay. I think that does it. Get to them all. Let's see. Yeah, that's everything. So we've got 4 minutes left. So if anyone has any more questions, please feel free to submit them. But otherwise, thank you everyone for joining, and thank you, Matt, for the presentation. It's fantastic.
Yeah, no problem. And yeah, thanks again, everyone, for coming, and feel free to reach out if anything else comes up later.
Oh, I'll do a quick word on the completion certificates before everyone goes. If you missed the beginning, we are going to try and get those out as soon as possible. So hopefully early next week. But yeah, please bear with us. There's a lot to get through. Okay. Thank you very much, and everyone have a great day.
Yeah, thank you.